What's going on, everybody? In this video I want to talk about how we can evaluate functions. And evaluating functions is very similar to evaluating algebraic expressions in the context that we're going to be plugging numbers in and then seeing what comes after we finish their arithmetic. So functions usually have the notation of something like this: y is equal to f of x. This can also be g of x or h of x or really any other letter that you want. This f is basically just used for naming whatever function we have. So the idea is to pick an x value and then shove it into the function, and then whatever you get out of it after you carry out all of the arithmetic operations is going to be y, which we call an output. So let me show you how this works with a few examples. So let's say that we have the function g of x is equal to x to the 4/3 power. So basically what it says is that the process that we're going to be going through in order to produce outputs is taking an input, raising it to the 4/3 power, and that's it. That's the entire function. So the way that this works is whatever number is inside your parentheses, that's the number that you're going to be shoving through the function and carrying out the arithmetic process for. So in the first one, I've got g of 8. So what I'm going to do is I'm going to take my function and just plug 8 into it. So I have 8 raised to the 4/3 power. And then you just see what you get from that. And so when I plug in 8 into this function, raise 8 to the 4/3 power, I end up with 16 as my output. So same thing here. If I plug in t plus 1 as my input, what I'm going to have is t plus 1 raised to the 4/3 power. And I don't quite know the expansion for that, but that's good enough. This is the output that I'm going to get. If I have a t in there, then a t plus 1 raised to the 4/3 is going to be my output. So the next one, if I have g of negative 27, same thing. I'm just plugging in negative 27 into this original function up here. So I'm raising negative 27 to the 4/3 this time. And now it's going to give me negative 81 for my output. And then lastly, I don't have to restrict it to just numbers. I can even plug in a negative x here and see what happens. So if I plug in a negative x to the 4/3 power, remember this is the same as me saying the cube root of negative x raised to the 4th, and a negative number raised to the 4th power is a positive number. So this is just going to give me, and the cube root to a positive number is just going to be a positive number. So this is x to the 4/3 power also. So suppose I had something like this. So this is what we would call a piecewise function, and it basically just splits the function into two separate parts at a specific x value. So in this case, that specific x value that we have is negative 1, so the function is going to change behavior as x goes from one side or the other to negative 1. And as you can see, it says when x is less than or equal to negative 1, the function reverts to 2x plus 1, and then all the numbers that are greater than negative 1, the function switches up its behavior to that of x squared plus 2. So that's the only added rule that we have for evaluating functions for piecewise ones. So let's take a look at what we have here. So h of negative 2, our input negative 2 is less than negative 1, so we're going to revert to 2x plus 1. So h of negative 2 is 2 times negative 2 plus 1, since our input is in this criteria here. So 2 times negative 2 gives me negative 3, plus a 1 gives me a negative 2 for my output. So moving on to negative 1. Negative 1 is included also in the 2x plus 1 because it says that x is less than or equal to negative 1. So what I'm going to do is I'm going to say h of negative 1 is equal to 2 times negative 1 plus 1, which gives me negative 2 plus 1, which is a negative 1 for my output. And then for h of 0, 0 is greater than negative 1, so it's going to fall into the second part of the piecewise function. So what I'm going to do is I'm going to do h of 0 into the second part. So this is 0 squared plus 2, which just gives me a 2 for my output. And then lastly, for h of 2, again, 2 is greater than -1, so I'm going to plug it into the second part of the piecewise function. So I'm going to say h of 2 is equal to 2 squared plus 2. 2 squared gives me 4, and then add that to 2 gives me 6 for this output. So pretty simple all in all. Functions are just machines that generate outputs based on what you give it. So you're going to get a specific output for a specific input, and the way that you do that is just working out the arithmetic that's described by each function. So I hope this video was helpful, you found some value out of it, and stay tuned for the next one. Take care, everybody.